All right, so we just said that because they end up kind of squished flat on each other, if they're the exact same size, it cannot form a triangle.
Yep.
Louise said, what if it was like 0.1 larger? Yes, it would. It would just be like a really tiny one like that. But watch this. If you have two that do not add up, this is a sum, right, when I put them together. If the two shorter ones don't add up to the longer one, then can you even possibly make a triangle? No, they won't reach each other. If you have two and they end up longer than the third side, then yes, you can make a triangle. So do you see the difference?
Yes.
Okay. So what if, I'm going to add another example in here before we do the other one. What if we had sides 5, 1, and 4? Could that make a triangle?
Yes.
Why are you guys saying yes?
No. 5, 1 plus, no, it wouldn't, because 1 plus 4 is 5.
Right.
And this equals.
And what were you guys tempted to do?
I was doing 5 plus 1.
Right. And that's why I did this example, because I realized I didn't have good examples here. It is the smaller two, not the first two.
Yeah.
Okay?
I was
All
about
right.
to ask you, like, how do you classify them? But then you said the smaller one.
Right. So it can't be. These are equal, not good enough. All right. So tell me a set of sides that cannot form a triangle.
6, 5, 1.
Good. Because 1 plus 5 is equal to 6, not more than 6. All right. Are there any other sides if you had 6 and 5 that you could put in there that would not make a triangle?
4.
3. That would work. 1 doesn't work. Does 2 work?
Yes.
Yeah, because 5 plus 2 is 7, and 7 is greater than 6. But we could maybe change the 6 and make it a 7, and then it doesn't work, right? Okay, what about us? If we yes. No, because it would be.
You said it doesn't or it does?
Doesn't.
Why?
Right.
Because
it make the 6 7.
Because if this was 7, 1 plus 5 is
6.
and 6 is not greater than 6 and 9. For this one or this one?
No, if it wouldn't make 7 5, that would have been great.
Right. All right. So tell me some sides that can make a triangle.
5, 6, and 10.
5, 6, and 10. Because 5 plus 6 is 11, and 11 it's okay. And 11 is greater than 10. Does that make sense? Okay. This should be. It doesn't make sense. Okay. This should be
Easy.
not easy, but it should become very simple. Like if I call out 3 numbers, you should tell me yes or no. And here's why that's important. Later, we're going to do right triangles. And there's a different rule. It still has to follow this rule and an extra rule. Okay? So we're going to talk about if I gave you only 2 sides.
Victor!
If I gave you only 2 sides, how could we find the third side? Okay? So,
We can just add a number.
yeah, so you're going to add the numbers together, the 2 that they give you, and then you're also going to subtract them.
I thought we were using the pattern there.
Not yet. That's right triangles.
All right.
Okay? Yes. You have chocolate in your
So
mouth?
you're going to add 4 plus 7
Oh,
is
no, wait till the notes are over.
1 6.
Well, hold on. I want to make this really clear. When you subtract them, you're going to do big minus small. Okay? Because what if you did the small one minus the big one? What kind of number would you get?
Negative.
And can you have a negative distance?
No.
Okay. So this is the way you do it, and now we'll show you what it would really look like. 4 and 7, we would add them and subtract them. What's 7 plus 4?
11.
What's 7 minus 4?
3.
Okay, so this is how you write it. 3 is less than x is less than 11. Write that down. And make that look important. We talked about this kind of notation in Algebra 1.
No.
We did. All right.
I
And
did.
what this means is that x is between 3 and 11.
So it can be
So I
any
mean
number between
7
those.
is.
Right. So it can be any number between 3 and 11. Can it be 3?
No.
Well, let's try it. 3 plus 4 is 7. Is that a triangle?
No.
No. So it has to be between 3 and
So it can
11.
be 4, 5,
It can be
3,
9.
7,
It could be 9.
10.
Yep.
9. 9 plus 3, 12.
Oh, for this
It's
one.
greater than.
Right. So we would do 9 plus 3 is 12, and 9 minus 3 is 6. So we would write 6 is less than x is less than 12. X is between 6 and 12.
That was how we made the 16 in decimals.
Yes. So if you had a side 6.5, would that make a triangle with 9 and 3?
Yeah.
Yes. If you had 12.5, would that make a triangle?
No.
No, because it's too much. Okay?
I can do that.
All right, and then this is the kind of question you'll see on tests and stuff, and these are the annoying kind because if you get all of them right but you miss one, it's wrong. If you get, because they count it right or wrong, you either get all of them or you get none of them. Okay? Or you get 2, but they count it as none. So in this one, we have 2 sides of a triangle that measure 19 and 34. We want to figure out all the possible sides. So what's the range? It's okay. What's the range of sides? How do we find where it could be?
19 plus 34.
Okay. And then Nancy, how do we find the other end of the range? Are we doing 19 minus or 34 minus? 34 minus 19. Does it matter if we do 34 plus 19? No, it's the same. So that would be 53, and this would be 15. So what's the range?
15.
50
Less than?
x.
Less than 53.
Okay. This is the range. So now we're going to look at our choices. Is 13 in this range?
No.
No. It's 15.
No.
34 less than 15. It's 24.
No.
All right. So some of you are saying yes to 15 and some of you are saying no. It's a no. Okay. Because that would be equal. So not 15. Yes to 21. Yes to 38. Yes to 52, but not to 59. Does this make sense?
Why?
Why, Victor? Because it has to be between them. So 15 is the smallest.
No.
Well, it
No,
can't.
es que 15 está ahí, man. De los cuadritos. Tiene que ser, man, ¿qué números hay entre 15 y 53? Después del 15 sigue el 16. Entonces tú solo puedes hacer del 16 al 52.